Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 1 to 5 of our next generation Accuplacer Arithmetic, Volume 3. Don't forget there are 5 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of the contents covered in this presentation. If you'd like to gain access to our entire course list and other valuable resources to help you with this test and your math courses in college, just visit our website at mathgotserved.com, or you can take a look at the links in the description below. All right, let's take a look at question number 1. On question 1, we're being assessed on how to convert decimals to fractions. Okay, so question 1 states, which of the following fractions is equal to 0.3? So we have the decimal here, and we're wondering which of these four fractions is equal to 0.3. All right, so before we get started, let's go over the steps for converting decimals to fractions. So first thing you want to do is you want to divide the decimal by 1, okay? So just express the decimal as a fraction, all right? So just divide the decimal by 1. If you divide anything by 1, you'll end up with what you started with, all right? And then after doing that, you're going to proceed to adjust the decimal point. How do you do that? What you do is you're going to move the decimal point. Move the decimal point, actually the decimal points in the numerator and denominator. An equivalent number of times So we're trying to get rid of the decimal point. So in order to get rid of it, what we're going to be doing is we're going to be moving the decimal points to the right direction so we can get rid of that decimal. Okay, so move the decimal points in the numerator and denominator an equivalent number of times to the right until what? Until the numerator is no longer a decimal. Okay, that's the strategy we're going to employ in solving this problem. So just a real quick review on how to convert your tenths into your fractional decimals into fractions and percents. So just a real quick review. This is something that is very important that you need to keep in mind for your test, okay? So 0.1. 0.1, if we follow this procedure here, can be written as 0.1 over 1. And in order to convert this into a non-decimal, we have to move the decimal point to the right one place, okay? So it's going to be 1 over 10. Alrighty, and if you want to write this as a percent, is the same thing as 10%. 0.1, 1 over 10, and 10% are all exactly the same thing, all right? How about 0.01? If you think about the place value, this is in the hundredths place. Why is that? Well, if you convert this to a fraction, you have to move the decimal point 2 places to the right in the numerator and the denominator. So you have 1 over 100. That is why it's called the hundredths. In percent form, this is equivalent to 1% because it's 1 per 100. Okay? How about 0.001? This right here is 1,000ths. Okay? You have to move the decimal point 3 times to the right in the numerator and the denominator to achieve your fractional form. And in percent form, this is 0.1%. This is a thousandths. So having this in mind is really easy to help you to convert decimals to fractions and also to percents. Now, let's go ahead and take a look at the problem. We have 0.3. Step 1 requires us to write it as a fraction, okay? So if we have 0.3, we're going to write it over 1. Okay, that doesn't change the problem. If you divide anything by 1, you end up with the original problem because dividing by 1 is like an identity operation, okay? So it's going to be 1 point. Now to get rid of the decimal in the numerator, that's the goal, we're going to have to move the decimal point one place to the right. Right there, bam. We're going to do exactly the same thing in the denominator, one place to the right. You have to move it an equivalent number of times. So put a 1 there to occupy the place, a 0. So this now becomes 3 over 10. The answer to question number 1 is C. And if you think about how to say this decimal, how do you say it? What place value does it occupy? It occupies the 10th place value. Okay, so 0.3 is the same thing as 3/10. And just by saying it, you can automatically know what the answer is. So another way to convert from decimals to fractions is by knowing the name of the place value of the digit that you're carrying out the conversion to, and then you are going to be able to easily convert it to its equivalent fractional form. Alrighty, so the answer to question number 1 is 3 over 10. Alright, for number 2, we've been assessed on how to multiply integers presented in word problems format. Okay? Question 2 reads, a class has 22 students. If each student donates 15 pencils to the class, how many pencils will the class have? Alright, so the formula that we're going to use to solve this problem is as follows. So the total amount is basically the number per unit. Okay, so in this case here, the unit is, we're dealing with pencils. The number per unit, so per unit is basically how many pencils does each student have. Okay, multiplied by the number of units. Number per unit multiplied by the number of units. Now, let's adapt this problem that we're dealing with here to this formula. And just a side note, if you'd like to gain access to the most known formulas for the Accuplacer, you can just visit our website at mathgotserved.com and you can gain access to that formula, to the formulas, and also a whole collection of formulas that will really help you do well in your mathematics studies. Okay, all right, so let's adapt this formula to this particular scenario that we're dealing with. All right, so adapting it to this problem, we have total number of pencils the class has. Total number of pencils the class has is going to be equal to the number of pencils per student. Okay, that's a number per unit. Each unit is a student multiplied by what? Multiplied by the number of students. Alrighty, so that's what we're going to do. So let's do it. So we have total number of pencils, and the class's number of pencils per student is 15 pencils per student. Okay, so it's 15 pencils per student multiplied by how many students in all? There are 22 students, so 15 times 22. Alrighty, so to do this, we're going to use our multiplication of 2-digit integer by a 2-digit integer. Okay, so let's go ahead and multiply that out. Make sure your place values line up perfectly. So we're going to multiply by the ones place first. All right, so we have 5 times 2. 5 times 2 is 10. 0, carry 1. 5 times 2 is 10 plus 1. We have 110. All right, and then we go to the tens place, put a 0 here. 1 times 2 is 2. And then 1 times 2 is 2. And then we just basically add it downwards. Alrighty, let's specify what our operations are. So here we're multiplying, and then we just add these up, and we're going to have 330. Okay, So the answer is 330. Answer to question number 2 is option letter C. Now, what's the significance of this answer? Let's go ahead and put the answer in context of what the question is asking, okay? So the final answer is the total number of pencils, the total number of pencils the class will have is 330. All right, so that's how you multiply 2 digits by 2 digits presented in a word problems format. Alrighty, let's take a look at question number 3. On question 3, you've been assessed on how to add fractions. In this particular case, we're looking at how to add fractions with unlike denominators. That brings up an important fact or point that you want to remember, which is as follows. Recall, in order to add or subtract fractions, you have to meet a specific condition, okay? In order to add or subtract fractions, the denominators must be what? The denominators must be equal. They must be equal to that number called the lowest common denominator divisor, okay? They must be equal to the LCD. All right, so let's take a look at the formulas for adding and subtracting fractions. These are also included in our must-know formulas to do well on the Accuplacer exam. So if you're adding two fractions with identical denominators, so let's say a over b plus c over b, how do you do it? You add or subtract the numerator and you keep the denominator. Okay? Now what if you're adding two fractions with different denominators, a over b plus c over d. So let's say that the denominators are co-prime. All right, let's say they have no common factor, no factor in common. Alrighty, so in a scenario like that, all you have to do is basically make the denominators identical. All right, so in order to do that, you're just going to multiply a over b by this denominator right here. So it's going to be AD times BD plus, and then you multiply the denominator on the left by the fraction on the right, CB plus, we can also write that as BD. DB and BD are the same thing since multiplication commutes. All right, this is assuming that the denominators have no common factors. If they have a common factor, then of course you will have to find the LCD, which will involve that common factor appearing just once. We'll see an example in a second, okay? So in this particular case, you make the denominators equal first, and then you proceed to apply the formula up here, combine the numerator, and keep the denominator. Alrighty, so that's exactly how you add fractions. Now let's attack the problem. We want to find out what is 2 over 10 plus 8 over 100. You can't just add the top and the bottom. You get 10 over 110, which is wrong. The denominators must be identical first. All right, so how do we make the denominators identical? Well, we have to find the LCD of 10 and 100. What is the smallest number that 10 and 100 can go into evenly? So the LCD of 10 and 100 is going to be 100. Why is that? Well, because 10 happens to be a factor of 100. So the smallest number that these two can go into evenly is the bigger of the two, since the smaller is a factor of the bigger. Easy way to do it. Okay? All right. Now let's go ahead and alter this fraction, expressing the first fraction as an equivalent fraction with the same denominator as the second. To accomplish that, you just multiply by 10, because 10 times 10 is 100. Alrighty, so we're going to have 20 over 100 plus 8 over 100. Now that the denominators are identical, we can go ahead and add just the numerator. Don't add the denominator, please. Just add the numerator and keep the denominator. That's how you add fractions. And you have the unreduced form is 28 over 100. Of course, you can reduce that to 7 over 25, but we're looking for the intermediate form. The answer to question number 3 is option letter B. Okay, so that's basically how you add or subtract fractions with unlike denominators. Alrighty, let's take a look at number 4. Number 4 is assessing us on how to add and subtract integers presented in a word problems format. Okay, alright, so problem 4 reads, a principal bought 312 brownies for the students and another 28 brownies for the teachers. How many total brownies did the principal buy for the students and the teachers? Alright, so let's go over the formula for scenarios like this, where you have two parts and you're asked to find what the part is together. So the formula is as follows. So total of the parts, in this particular case we have two parts, total of part 1 and part 2. Together is what? Well, since you're looking at what they are together, all you're just going to do, the operation here is you're going to add, okay? So it's going to be number in part 1 plus number in part 2. And that's going to be the answer. All right, so in this particular case, what are we looking at? Brownies. So let's adapt this formula to the scenario that we're looking at. So the total number of brownies is going to be the number of brownies in part 1. So part 1 is what? What is part 1? Students. So that's part 1. Let's call that P1. Number for students. Number for the students, part 1, plus part 2, which is what? The teachers. The number for the teachers, we're going to call that P2, okay? So P1 for the students, P2 for the teachers, so plus the number for the teachers. And we're going to put it into this formula right now. So number for the students, number of brownies for the students is 312. Plus the number of brownies for the teachers, which is 28. Okay? All right, so let's add it up. 3, 1, 2. So when you're adding two integers, please make sure that you align them in such a way that the identical place values are vertically configured. Alrighty, so you have we're just using the stack method here to add these two integers. So these are the ones place, so line it up. You don't want to put the 28 here and mess up the whole sum. So nicely lined up, let's go ahead and add. 2 plus 8 is 10, 0 carry 1. 2 plus 2 is 4, 340 is your answer. So the question to number 4 is 340. That's the total number of brownies for the students and the teachers combined. Okay, answer to question number 4 is option letter B. All right, let's take a look at number 5. In question number 5, we're being assessed on how to find the percent of a whole. Alrighty. Question 5 reads, a bakery made 80 muffins. They sold 36 of those muffins. What percent of the muffins were sold? Okay, so the part is 36 and the whole is 80. All right, so 36 out of the 80 were sold. So what is that in percent format? That's the question. All right, so let's take a look at the formula. Another formula that you can access on our website, mathgotserved.com, is the formula for finding the percent of a whole. All right, so how do you do that? So to find the percent of a whole, what you do is you divide the part by the whole, either using long division, or you can just use reduction of fractions, and multiply your answer by 100. We're going to do this in two different ways for you to see, and whichever method that you like, you can employ. Okay. All right. So method one, we're not going to use long division. We just use reduction of fractions. All right. So method one, we're going to use reduction of fractions. All right. So in this particular case, let's adapt this formula to the particular scenario that we are dealing with right here. Okay, so what we're looking for is percent of muffins sold. So percent of muffins sold is going to be number of numbers sold divided by total. All right, this will give us the fraction sold as part of a whole, okay? Multiplied by 100. Let's do it. So the number sold is what? 36, all right? So 36 divided by the total is 80. So this is the fraction sold, part of a whole. So let's convert this to, so we're going to multiply this by 100. What does this multiplication by 100 mean? Well, it's just converting your fraction into percent form. Alrighty? But if you divide this using long division, you end up with a decimal. And then you just multiply by 100 to convert it to percent. So let's see. How do we reduce this? How do we reduce this product of fractions? So first of all, express 100 as a fraction. And let's see, what can we do here? We can divide out the 10. So if you divide by 10, you just cancel out the zeros. And then let's reduce, does 8 and 10 have anything in common? Yes, they both have 2 in common. So we can divide 8 by 2, which will give us 4. And then we can divide 10 by 2, which will give us 5. 4 and 36. Do they have anything in common? Absolutely. They have. They will have 4 in common, right? So we can divide top and bottom by 4. So divide 4 by 4, that's 1. Divide 36 by 4, that's 9. Nothing else to reduce. Multiply across. 9 times 5 is 45 over 1, which reduces to 45%. And there goes your final answer. The answer to number 5 is option letter D. Okay, so let's take a look at another method of doing this. Method 2 involves long division. We're going to use long division and then decimal to percent conversion procedure. So it's no different from what we have here. So this fraction right here, 36 over 80, we're going to divide it. All right, we're going to do a long division. So 36 divided by 80. So the top dog goes in the dog house. So the numerator goes right here and the denominator goes on the outside. Okay, so how many times does 80 go into 36? 80 is bigger than 36, so a number can't go into something that's smaller than. So what we're going to do, put a decimal point and add a 0 right here. How many times does 80 go into 360? So to do this, we say how many times, look at the first digits, okay? So How many times does 8 go into 36? How many times does 8 go into 36? 8 goes into 36 uh, 4 times, right? All right, so if you do your 8 times table, that's what you get. It goes into 36 4 times, and then 4 times 80, I'm sorry, 4 times 80 is going to be 320. So you multiply these, you have 320. And then you subtract. And what do you have left? 6 minus 2 is 4, 40. All right, so how many times does 8 go into 40? 8 goes into 40 5 times. Okay, so we have to... All right, so since 5 is located in the hundredths place, we add a 0 here first. All right, so you want to make sure that the digits line up perfectly. All right, so let's go back down. Sorry about that. Okay, so 8 goes into 45 times. 80 goes into 400 5 times also. So 5 times 80, you have 400. And then when you add it all up, you end up with 0. Alrighty? Okay, so we can clearly see that 36 divided by 80 is 0.45. Okay, so how do we convert 0.45 into percent? How do we do that? Well, all we just do is we divide it by 1, just like we did in the first problem. And then we're going to 1.0. Move the decimal point an equivalent number of places until the denominator is 100. Okay, so we're going to move it 2 places. 1, 2. Bam. So in the numerator, the same thing. 1, 2. Okay. Easy way to convert from decimal to percent is to move your decimal point 2 places to the right. That's exactly what we're doing here. I'm just showing you the mathematics behind it. You have 45 over 100. Well, what does that mean? It's 45%. Okay, think about cent a century. 45 over 100 is 45%. Okay, so just keep in mind that 0.45, 45 over 100, and 45% are all exactly the same thing. And you should be able to convert from one to the other. Okay, we have decimal, fractions, and percent. Answer to number 5, as we can clearly see, is option D. Okay, so which method do you prefer? Going to decimal and then converting to percent, or just reduction of fractions? Let us know in the comment section below which method you prefer and then why. Or maybe if you have another more creative method, just specify it in the comment section below. Practice. These are the 5 practice problems we'd like you to try out in order to demonstrate mastery of what we just covered in this presentation. What I'd like you to do at this time, go ahead and pause this video presentation, try out these 5 problems. When you're done, click on the play button and we will reveal to you what the correct answers are. Welcome back. So hopefully you had a chance to try out the problems. Let's take a look at what the answers are. To question number 1, the answer is option letter D, 8 over 100, 8 hundredths. Number 2, the answer is option letter D, 392. For question number 3, the answer is 31 over 100, option letter D. And then for number 4, the answer is 402 binders total. Option C. Question number 5, the answer is 60%. So how well did you do in these practice problems? Well, let us know what you got, your score in the comment section below. If you had any questions on any of these problems in this practice set or what we covered, just let us know and we'll be glad to assist you. If you have any other special requests or any other thing, just let us know also. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this presentation helpful in your preparation for the upcoming Accuplacer, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel. We upload math tutorials to our page on a regular basis, so go ahead and do that. And as indicated earlier, questions or comments should be included in the comment section below, and we will try our best to respond. To gain access to other valuable resources, including our interactive practice tests, take a look at our website at mathgotserved.com, or you can just take a look at the links in the description below. Thanks again for watching, and have a wonderful day. Goodbye.